Oh, again, it's me again. So there are two talks coming up. He's modelling it in slightly different ways to look at related issues. So this first talk on top-down and bottom-up control, we're really trying to use the evidence in the data that we have to try and infer whether or not top-down and bottom-up control are happening in the North Sea ecosystem and how strong those effects might be. Why do we want to do this? Well, we want to investigate the response of the system to contrasting pressures of climate change and fisheries impact. And it's often argued that you can't disentangle the two things, but we're going to try our best just with the data here to look at the relative importance of climate versus fishing. And also because we want to know about prevailing climatic conditions, because they're relevant to many of the indicators. So these are the components that we're going to try and model using data. So we have spawning stock biomass information, fisheries, stock assessments, and fishing mortality on every species. This was started before we did the primary production work, so here we're only using information from the continuous plankton recorder for the planktonic groups. And basically we've taken lots of data, a long time series back to 1964, and done lots and lots of statistical GAMs and T-GAMs to try and link together the different components with simple models where possible. So we limited the wiggliness. And to make the technique work, we were trying to find links between trophic groups. So after doing lots and lots of submodels for every component, we create this thing called an interaction web. So it looks a bit like a food web, but it's not a food web. It's just showing the significant relationships between the different components based only on the GAM analysis. And if we really struggled to find any links between them, we went to T-GAMs, which allow relationships to change over time, but we don't have very many of those. And once we create this interaction web, we then say, well, how can we use that to do predictions and scenario testing? And if we take just the initial conditions in 1964 and then use the drivers for sea surface temperature and fishing mortality, can we recreate the time series and then can we alter them using scenarios? So this is what the predictions look like, just using the data in 64 and the time series of sea surface temperature and fishing mortality. And you can see that we actually recreate the data, the dots, surprisingly well. And we were quite pleased with this. So the best fit there, in the median line, is the white line, and then we're showing the variability around all the simulations or the predictions from the linked GAMs. And so the more red it is, the more certain we are about that area being likely, and the more broad and pink the error bars get, the less certain we are. And so what we can see is there are some direct linkages between the climate, temperature, and some of these groups. But there are also indirect things emerge from the model. When you start pushing the linked GAMs, you see indirect cold preferences and warm preferences due to bottom-up processes affecting the prey groups. And we also see top-down effects emerge from the model. So although fishing mortality didn't go in any of the GAMs we actually used to predict the relationships with the copepod groups, once we stressed the interaction web, we could see some responses, which was quite surprising. And we see some strong effects due to fishing on three species, on sand eels, cod, and the herring. And some strong effects of temperature directly on cod and sand eel. They prefer the colder temperatures. And again, we did the data in this predictive way quite well. And then we see some weaker effects on fishing, on herring, on sprat, on sei. But other species like whiting, they're just more responsive to food web interactions, particularly in this scenario where it's actually their prey groups which are more predictive of their biomasses than the actual temperature itself or the fishing mortality. And again, we start to see some indirect effects of bottom-up control emerging, where some of these groups link to temperature, not through the relationships that we fitted themselves, but through the relationships lower down in the trophic level, which then when we've predicted from, and they're all linking and predicting each other, you start to see these indirect effects emerging from the statistical model. So we're then trying to draw out from that interaction web the key links that there are. And the thick arrows here are strong relationships, where the proportion of variance explained by that relationship was particularly strong, and the dotted relationships are quite weak. And we see the link between bottom-up, the planktonic regime, and the fish here is actually through only weak links. So there are links that emerge from the model, but they're quite weak. So the climate is really affecting the plankton and creating this regime shift. People talk about that you could see in the data there in the two groups of catalysts switching and the change in the greenness. But that isn't really cascading all the way up to the fish, because the fish are being strongly controlled actually through fishing more than anything. The top top-down links here, represented by the vessels producing the fishing mortality, the key links we found were actually through fishing on sand eels and fishing on herring and other planktivorous species. So these forage fish are really key in the food web. And then they would have a knock-on effect, again through very weak links, onto the plankton. So you can see that the fishing has quite a stabilizing effect actually on the fish over this time period, such that sort of cascading regime shift doesn't seem to emerge into the spawning stock biomasses because we're really impacting them and controlling them quite strongly. But nevertheless, the links are there, and as we reduce fishing mortality in the future, they become more important. And we can also see, using this very rough seabird group that we have on seabird breeding success, so there are some key pathways to breeding success emerging from the model. So sprat and sand eels seem to be the key species, as we might have expected, and fishing on those can impact the prey, therefore, for the seabirds. But there's also another bottom-up thing through the plankton, which seems to infer that when the system is just generally more productive, we get more production of seabirds as well. So there are these sort of two relationships, and we are missing lots of species in this because we're only using those where we have lots of data for. So perhaps the bottom-up productivity arm here is perhaps responding to some of these other groups which we haven't actually implicitly modelled. But now that we have an interaction web model of the system, we can then use it to look at scenarios for some of the indicators. So we learned about the donuts earlier, for the life form indicators, and this is an approximation of one of those donuts really, the diatoms versus dinoflagellates, how it might shift given stresses through to temperature and fishing mortality. And although this isn't published yet, we hope it will be soon. We're submitting it to PNAS shortly. This has been bobbing along for quite a few years under the project. Really hoping to get this out quite soon.